In this video, I'm going to talk about the const modifier that you'll sometimes see on class member methods. So here I have a class, and I've called it const class, that has a private member called num. It has a constructor, and then so far there's two methods. There's print, which prints the number, and then this func method that just prints out the number as well. So they do pretty much the same thing, but we'll actually modify this in a moment. So I declare an object of constant type, and then I print out the name of the object and then call the print and functions. So if I compile this, you'll see that we print out that information. So now let's create a constant object, and we'll initialize that with 10. And to say that it's a constant object, we declare it with a constant keyword. So now I'm going to call the same methods, and let's compile this and see what happens. So you'll notice there's an error. Passing const class as this argument discards qualifiers. So if I go to that line, which is line 23, it's this line right here. If you're wondering what's going on, we'll notice this is a constant object, but then I'm calling a class method. Well, what's to stop that class method from changing the object? Well, it says it's a constant object, so if my class method gets called, maybe that gets changed. So what I can do to get rid of that is I can make it const. So what's going on here? So print should not change the object. We're going to declare it const. Now func, I'm not going to say that maybe this can change the object, maybe it won't. So I'll create a separate constant function, func. And in this case, it's important to keep in mind that const is part of the method signature. So func is overloaded here. There's two func methods. There's one that's constant and one that's not. So now let's compile this and run. And you'll see the constant object calls the constant function. The non-constant object calls the non-constant function. So I think we need to add an inline here. Okay, so let's create two pointers. We'll create one const class pointer, and we'll set that to the non-const object. In fact, let's do the same thing to the const object. And then compile and run. Let's give it a different name. So we'll call this const pointer. I think this should be lowercase. So we've cleaned up most of the bugs, but now notice we get an invalid conversion from const class pointer to const class pointer. So it wants this pointer to be constant. So to make that compile, I need to say, look, this is a constant pointer. I'm not going to use that pointer to change what it's pointing to. So we have some unused variable things. That's okay. Here we go. Okay, so we've declared our pointer. So now let's use those. So first, let's print the non-const pointer to non-const object. So we say pointer print, and we say pointer func, and we'll do an inline as well. And then we'll do the same thing for const pointer. And let's print those out and see what the result is. So you see that when we use the non-const pointer to non-const object, it calls non-const function. And the same thing for the constant objects, which we would expect. So let's take this code, and this is again the non-const object, but let's say that const pointer is going to be the address of non-const object. What's going to happen then? And we print this. Let's back all that up because this should be const pointer. There we go. So when we compile and run, you can see that now that this is a const pointer to the non-const object, we call the constant function. So again, because we're treating it as a constant, we're saying, hey, this is a pointer to a constant object, so then that constant method is the one that gets called. So one more example. Suppose that we have a function that takes a constant reference, and it's going to do the same thing we did before. So let's pass both of these objects there and see what happens. So here we're going to say func const obj. I think we call that stuff. We'll say stuff const obj, and actually we'll do non-constant first. I think that's how we've been doing it so far. So then we'll say non-const and non-const. So if we run this after we compile, we'll see that when we call it with non-const object, we still get the const because it's a constant reference. So that constant reference means I'm going to treat what I'm referring to as a constant, so we call the constant method. So something to keep in mind, it really can get tricky with inheritance and so forth, since these are two separate functions that get called. If you have them both, the one that gets called depends on whether or not the calling method is constant. And if you have a constant object, then you can only call constant methods on that object, because it wouldn't allow you to call something that allows the object to be changed.